Another way you can compare the relationship between two variables using simple statistics is through a scatterplot. A scatterplot is useful when you have interval or ratio level dependent and independent variables. In order to illustrate how to set up a scatterplot, I will start with the following hypothesis. As government spending on health as a percentage of GDP in a country increases, life expectancy at birth in the country increases. In order to see if government spending on health as a percentage of GDP in a country has a positive effect on life expectancy, I can set up a scatterplot between government spending on health and life expectancy. The first step in this process is drawing a graph and placing the dependent variable name on the y-axis. Step 2 is placing the independent variable name on the x-axis. The third step is placing the appropriate values of the variables on each axis. The fourth step is placing a point on the graph for each observation. The fifth step is analyzing whether the relationship between the two variables is positive, negative, or neutral. So in order to analyze whether government spending on health as a percentage of GDP in a country has a positive effect on life expectancy, I would put the dependent variable name life expectancy on the y-axis. Then I would put the independent variable name public expenditure on health on the x-axis. And since, based on the data I have collected, life expectancy ranges from about 30 to 90, I place 30 to 90 on the y-axis with appropriate 10-point intervals. And since, based on the data I've collected, public expenditure on health as a percentage of GDP ranges from about 0 to 12, I place 0 to 12 on the x-axis with appropriate 2-point intervals. Then I go through each observation and make a point on the plot for each observation. Here is an example for observation 1. Public expenditure on health was 1 and life expectancy was 83. So I place a point on the graph where public expenditure on health was 1 and life expectancy was 83. Then I continued this process for the rest of the observations, and this is the result. The next step is interpreting whether the linear relationship between the two variables is positive, negative, or no relationship. Recall that in a positive linear relationship, as the independent variable increases, the dependent variable increases at a constant rate across all values of the independent variable. Recall that in a negative linear relationship, as the independent variable increases, the dependent variable decreases at a constant rate across all values of the independent variable. When there is no relationship between the independent and dependent variables, as the independent variable changes, the dependent variable stays the same. In order to figure out if the relationship is positive, negative, or neutral, you should draw a line through the middle of the observations. If the line has a positive slope, then you conclude that there is a positive relationship. If the line has a negative slope, you can conclude that there is a negative relationship. And if the line has a slope of 0, you can conclude that there is no relationship. So going back to our example, the scatter plot suggests that there is a positive relationship between public health expenditures and life expectancy. So we can conclude that there is a positive relationship between public health expenditure on health as a percentage of GDP in a country and life expectancy in a country. As public expenditure on health as a percentage of GDP increases in a country, life expectancy at birth in a country also increases. In this lecture, you were introduced to 3 ways in which you could use simple statistics to analyze the relationship between two variables: a cross-tabulation table, a mean comparison table, and a scatter plot. It is important to note, as I discussed in the lecture, that the type of variables you have, nominal, ordinal, interval, and ratio, will determine which type of method you should use to analyze the relationship between two variables. You can use this metacognition card to determine which statistical method to use given the types of variables you have. If you have nominal and ordinal level dependent and independent variables, use a cross-tabulation table. If you have a nominal or ordinal level independent variable and an interval or ratio level dependent variable, use a mean comparison table. If you have an interval and ratio level dependent and independent variables, use a scatter plot. In the next few slides, I'm going to show you how to use the metacognition card to make a decision about which type of method to use to analyze the relationship between two variables. Consider the following hypothesis. Non-white voters were more likely to vote for Obama than white voters were in 2008. The dependent variable is vote choice, Obama versus McCain. Since this is a categorical variable and there's no order to the data, this is a nominal level dependent variable. The independent variable is race, white or black. Since this is a categorical variable and there's no order to data, this is a nominal level independent variable. Since the dependent and independent variables are nominal level, we should use a cross-tabulation table to analyze the relationship between race and vote choice. Using data from the GSS dataset, I created a crosstab of vote choice and race. I placed the dependent variable categories Obama and McCain in the appropriate rows. I placed the independent variable categories white and black in the appropriate columns. I added a total row and a total column. I calculated how many observations fit into each cell. For example, there were 476 survey respondents who said they were white and voted for Obama. Then I calculated column percentages for each of the cells. Then I compared across the rows to see if non-whites were more likely than whites to vote for Obama, which is what my hypothesis suggested. Based on the results, I can conclude that black voters were more likely to vote for Obama than white voters were. 99.18% of black voters voted for Obama, while only 52.29% of white voters voted for Obama.